Here's our problem for today. We have a circle, we also have a square, and square intersects circles in several places. So point A and point D, the corners of the square, are on the circle. Point F is a point of intersection of the side CD of the square. AF is the diameter of a circle. Point E is the point of tangency to the side BC, and point E splits the side BC into two congruent parts. And the question is, what's the area of the square ABCD? The way we're going to solve this problem is probably not the fastest one, so I encourage you to find other ways that may be faster than this one and publish them, put them in the comments. But the way we're going to go about this problem is, first of all, notice there's point E sitting here, kind of not connected to anything. So let's connect it to point F and point A. Now, what we find now is this angle AEF is actually 90-degree angle. And it's 90-degree angle because of Thales theorem, which tells us that if you have an angle, which is inscribed angle here, that sits on a diameter, that angle has to be 90 degrees. And now to solve this problem, we really need to apply Pythagorean theorem 4 times to 4 different right triangles. Before we do it, let's denote the side EC as A. In this case, the side BE is also going to be A. And the side of the square will be 2A. And now let's consider this blue triangle ABE. And let's apply Pythagorean theorem to this triangle. So what we find that AE squared will be equal to 5A squared. The next thing we're going to do, we're going to apply Pythagorean theorem to this red triangle, ECF. Now before we do that, let's denote side CF as X. And in this case, EF squared will be just A squared plus X squared. And now we can combine those two guys right here by applying Pythagorean theorem to this yellow triangle, AEF. The Pythagorean theorem tells us that A squared plus EF squared equals to 10 squared. And now we're going to just substitute this and these values for AE squared and EF squared into this Pythagorean theorem. That gives us this expression, which is actually one equation for 2 unknowns. That's not enough to resolve this. We need another equation. And another equation is actually Pythagorean theorem applied to this purple triangle, AFD. Notice that AD is 2A and DF is 2A minus this X. So if we apply this theorem here, open the parentheses, that's what we're going to get. The next thing we're going to do is we see there are 2 equations and 2 unknowns. So we can potentially solve this problem. What we're going to do, we're going to subtract this equation from this equation. And then we're going to rearrange the terms a little bit. And what we end up is very simple, that X is A over 2. And then we can substitute this value of X into the first equation right here. And from there we can find the area, which is 4A squared, which is equal to 64. And that's it. And we're done.